Okay, this video is on solving quadratic equations using square roots. Now, we've already seen how some quadratic equations can be solved by factoring. And in fact, that's been the main method that we've been using so far to solve quadratic equations. For example, let's say I had a quadratic equation x squared plus 6x plus 5 equals 0. Well, I can factor this quadratic expression, and it will factor into, let's see, 1 times 5 will give me 5, and 1x and 5x, so plus 1 and plus 5. It will factor into the factors x plus 1 and x plus 5. And if I take each one of these factors, since they're multiplied together to give 0, if I set each one of these factors equal to 0, then I can solve for x. So x plus 1 equals 0, or x plus 5 equals 0. And I can solve each one of these for x. If I subtract 1 from both sides here, I get x equals negative 1. Subtract 5 from both sides here, and I get x equals negative 5. And I just solved this quadratic equation by factoring. Well, it turns out other quadratic equations can be solved just by using square roots. And in particular, quadratics that have a b value that's equal to 0 can be solved this way. Remember, a standard form of a quadratic expression looks like this: ax squared plus bx plus c. Well, when this b value is equal to 0, so you don't have this middle term here, then you can solve the quadratic equation using just square roots. So let's take a look at a couple of examples like that. So example number 1, x squared minus 100 equals 0. Now this is actually a quadratic equation that we've seen before, and we could solve this one by factoring. I notice that this is the difference of two perfect squares, and I know how to factor the difference of two squares. It always factors the same way. It would be the square root of this term plus the square root of this term. That'd be one factor, times the square root of this term minus the square root of this term. So x plus 10 times x minus 10. That would be how I would factor this difference of two squares. And then I would just do what I've always done before, which is take each one of my factors, set them equal to 0, and then solve this. Subtract 10 from both sides here, and that would give me x equals negative 10. And if I add 10 to both sides here, then I'd have x equals positive 10. And there would be my solutions. Well, I can also solve this one without factoring. I could solve this one just by using square roots. Notice that if instead of factoring this expression, if I just take this part, my number part, my constant part, and get that to the other side of my equation, in this case by adding 100 to both sides, well then, my equation now looks like x squared equals 100. Well, I can solve this one just by taking the square root of both sides of my equation. So, square root of this side, square root of this side. The square root of x squared is x, and the square root of 100 is 10. Now, when I say the square root of 100 is 10, that's true, but remember that for a quadratic equation, I always expect to have two solutions. And in fact, this quadratic equation does have two solutions. Not only does it have a solution x equals 10, it also has a solution x equals negative 10, because 10 times 10 will give me 100, and negative 10 times negative 10 will also give me 100. So positive 10 is one solution to that equation, and negative 10 is also a solution to this equation. So sometimes you see this written as x equals 10 or x equals negative 10. Sometimes you see this written kind of all just in one statement like this: x equals plus or minus 10. So there's my two solutions: x equals positive 10 and x equals negative 10. All right, let's take a look at example number 2. X squared minus 19 equals 0. In this example up here, number 1, you might have said, well, why do I need to use square roots here? I can solve it, just fine by factoring. Well, sometimes you have an equation and it won't factor. Like this is the difference of two numbers, but this number here, 19, is not a perfect square, so it's harder to factor. You can't do that one as easily. Well, it turns out though, if I use this method here, it's very easy to solve. If I just add 19 to both sides, then I get x squared equals 19. And now I'm going to do what I did before, which is take the square root of both sides. Oops, that should be an x squared. I take the square root of both sides of my equation. The square root of x squared is x, and the square root of 19. That one won't simplify any further, so I would just write that as the square root of 19. And again, I want to remember to put down my plus and my minus because I've got two solutions to this equation. The positive square root of 19 and also the negative square root of 19. So this would be the solution to this quadratic equation. Example number 3. Now here I have another quadratic equation, and I can see that again my b value is 0. I don't have a middle term. I don't have an x term. So I'm thinking I can use just square roots in order to solve this equation. So I want to get all of my numbers on one side of the equation so that I'm left just with x squared on the other side of the equation. So let's see. If I add 31 to both sides here, my 31s go away here, and I've got 3x squared equals 31. All right, now notice I'm not ready to take the square root of both sides yet because I don't have just x squared on this side of the equation. I want to get just x squared. Well, that's not hard to do. If I just divide both sides of my equation by 3, then that will get rid of the 3 on this side of the equation. So my 3's cancel out, and now I have x squared equals 31 divided by 3. Now, even though this is an improper fraction, I can still, since I've got x squared on this side and I've got a number on this side, I can take the square root of both sides of my equation, and that will be the last step in solving my equation. Square root of x squared is x. The square root of 31 over 3, again, that won't simplify. I don't have any perfect square numbers under my square root sign, so I'm just going to leave this as the square root of 31 divided by 3. And once again, I need to remember I want to put plus and minus because I have a positive solution and also a negative solution. All right, example number 4. Now, at first glance, this one might look a little bit more complicated than the others, but with a little bit of algebra, it becomes a lot simpler. So again, I can see I've got a quadratic equation because I've got my x squared term here, but it doesn't look exactly like my others. Well, it turns out though, look, if I add 2 to both sides, then I can get all of my constant terms together. My 2's go away here. Now I've got 1/3 x squared on this side, and I've got 13 on this side. And once again, I see that I can't take the square root of both sides yet because I don't have my x squared term all by itself. It's got this fraction in front of it. It's got this 1/3. Well, I can take care of that by, this time instead of dividing both sides by a number like I did over here, if I multiply both sides of my equation by the number 3, well, that will get rid of my fraction here. So let me multiply this side of the equation by 3 and multiply this side of the equation by 3. So 3 times 1/3, here my 3's will cancel out, and I'm left with x squared on this side. 13 times 3 equals 39, and now I have a very simple quadratic equation that I can solve using square roots. So again, I take the square root of both sides. The square root of x squared is x, and the square root of 39, again, I can't simplify that any further because I don't have any perfect square factors under my square root symbol. So the answer here is just x equals positive 39 and x equals negative 39. And there's the solution to that quadratic equation.